Kind of. I'm just going back through and writing the formulas down just so I can kind of understand what's going on.
How many numbers is this? What is our n? 15? So, Colby, do you want to work the whole thing? I just filled in the equation to make sure that I was doing it right, but have you solved for it yet?
For number two,
Yeah, or do you just want to move on?
uh, yeah, I got the confidence interval.
Okay.
I got 51.622 upper bound as the upper bound. Is that good
Okay.
enough?
I was just plugging in the lower bound. Let me finish this one, then if I get this right, then
Um,
just go
I
forward.
got 1.845 as a lower bound.
40 what?
41.885 as bound.
Okay. 2, 7, 7, 7. And then 2. Wait, I think I might have. Hold on, let me make sure I'm doing this equation right. Okay, times 2.1448. And then 46.7. Okay, so 41.845.
Yeah.
Okay, thanks for reading for me. I got it. Okay, so Fran, I think we're gonna should we just all start on number 3 together?
Yeah, that'd be fine.
Okay. Okay, now create a 99% confidence interval to estimate the mean age of all children who build an investment property. Follow the same rounding rules as above. Do not overround when making them. The t-score for the 99% is 2.9768. Okay. Oh, okay, so for the lower bound, I got 7. Okay, for the lower bound, I got 39.9484. What did you get?
I got 39.949.
Okay, so maybe I just rounded. We just may have rounded differently. But I got everything the same until instead of 949, I got 94843. So, I mean, it's like to the fifth digit.
Uh-huh.
I probably just rounded wrong. But I tried to do it all the way.
This is pretty close.
Yeah, I say we're good.
Hey guys, I have a quick question for you.
Yeah, right.
I just want to make sure like I'm caught up and I understand what's going on. So for the confidence interval formula, I got bar x plus or minus t times s over the square root of n, right?
Yeah.
So for the bar x, or like the mean, I guess, am I just supposed to add up all of those numbers and divide by how many there is to solve for the mean?
Yeah, that's when you came in. Colby had already done it, but I tried to do it on Excel, and for some reason I was getting a different number than Colby, so I just typed into the software that I had us download. So yeah, I just typed it into that program, and it gave me the mean and the standard deviation. But yeah, you're right. We're supposed to solve it for that data first.
Oh, okay. I just wanted to make sure I was doing it right. And then the s is supposed to be the standard deviation, right?
Yeah, just have the data you got there. Yeah.
So to find standard deviation, do we just plug our mean into that applet?
No, the standard deviation is like a different formula.
Oh, we
So
have to.
it's actually like if you do like a data analysis on the SPSS, it will give you the mean.
Oh.
But I can't remember the formula, but there's a formula for standard deviation to also solve it. I think that's where you take like each data point you have to minus from the mean of the data. So it's like x minus bar x, and then you square it, and then I think you divide it by something, sum them all together. Anyway, there's an equation on that you can do, but you can just type it into Excel and it will figure it out for you.
Oh, Excel will do it for you?
Yeah. Or I would just
Okay.
do the SPSS and stick it in there, and it'll give you the mean, the standard deviation, everything that you need. Still my
Wow.
chocolate. I know.
I still don't even know how to use those programs.
Yeah, I had to watch those videos pretty carefully to sort of felt like I got it.
Hey, so if you put in the mean into that program, it'll solve for your standard deviation and whatnot.
Yeah, if you put in all the data points, they'll give you the standard deviation and everything you need.
Oh,
But
okay.
we could just also yeah, I guess let me know how that's going for you. If it's hard, then we can just share the mean and standard deviation.
Oh, yeah. No, it all makes sense. I just got to figure out how to compute on Excel because it's a way bigger pain trying to do it by hand. Right? Well, that's all right. Don't let me hold you up. I mean, I understand the gist of it, so don't let me hold you up. If you guys are ready to move on, that's fine. I'll figure it out.
No worries, that's fine.
Yeah, no problem.
Okay, alright. Okay, so uh, Okay, so now we pretty much, on question 4, now we just do the exact same thing on the computer.
Yeah.
So doesn't it already show, oops, I opened the internet on this thing. Doesn't it already show us that?
It tells you for the 95, make it 9. You go to explore. You have to click on statistics on the side. There's like bootstrap options, and there's plots. But you click on statistics, and then you can change the confidence interval for the mean to 99.
Okay, where is the statistics button? So sorry.
Oh, sorry. You go to explore.
Okay, I heard you say, wait. I don't have an Explorer on mine. Oh, yes, I
Go to analyze.
Okay. Walk me through this baby step by baby step, and then maybe I'll get it. So sorry. Okay, so analyze, reports, no. Descriptive statistics, explore. Oh, dang it, clicked on the wrong thing.
And then you click on statistics right there.
Oh, got you.
Yeah.
Genius.
Otherwise, I'll
Yeah.
keep 95% confidence
Yeah,
interval.
thank you. So, for the 95%, that's what, oh man, we got something different. Oh no, that's what we got too.
Mhm.
Woohoo! So we were right. Nice job. So how does the margin of error for the two compared for them? Oh man. So the margin of error, is that the standard error on the side or?
Margin error was like the standard deviation. It was the t-score times standard deviation divided by size.
T-score times the standard deviation. So we have to solve for this one then here, right? I was thinking it showed us on the statistic.
Yeah. When is it? The answer you get for B is the same as you get for number 3. So if you were to like compute the margin of error for 2 and 3, you'd see that 3 has a larger margin of error.
Sorry, explain it one more time. I'm so sorry, Toby. I cut out.
Oh, yeah, no problem. The margin of error for the 99% confidence interval will be larger. Pretty much.
Okay. Gotcha. Fran, do you have any questions on that?
Not so far. Just following everything.
What did you say?
But not so far. I'm just listening to what you guys are saying.
Okay. Should we go on to number 6? Are we okay with that?
Are you talking to me?
Yeah. Sorry,
Oh.
I can't see the screen. So.
Oh, yeah.
Okay. Anyway, yes. Okay. Rather than estimating the age of his clients that buy investment properties, a realtor agent would like to test the claim that the age of his clients is different than the national average of 47. Use a 0.05 as your confidence level of significance. Follow the following sequences of steps. Fill in your answers to each step and show all your work. Okay, so the null would be n equals 47. That's what they believe right now?
Yeah.
And then
Okay, the alternate. What? Sorry, what?
Oh, I said yes, and then not equal for the alternative.
Perfect. Okay. B. Compute the test statistic. First compute it using the formula showing your work below, then check it by imputing it into the data software. So the test statistic would be the t-score.
Yes.
So t-score equals how? I think. Hold on. Man, I need like 600 screens when I'm doing this. Okay, so for this one here, so we have x minus mu and divided by s over the square root of x. But do we even have mu for this?
I think we.
Oh.
So the
Oh, go ahead.
47. I believe you assume that
That
the null is
47 is the mu.
true. Yeah.
Okay. Oh, and then our x is the 46.33.
Yeah, I believe so.
Oh, so okay, that makes so much sense. Okay. Divided by 8.8257.
Question.
Yep.
So what does mu stand for in this situation?
That's what I was just on that same question. What the average they think is right now, which they think it is 47.
What's our mean then?
It's the mean of this test, the data that we have that you click into Excel.
Oh, okay.
Yeah. I just had that thing. I was like, wait, how do we figure this out?
Okay, that makes sense.
Okay, so for the t-score, I got negative 0.2926.
Oh, I got negative 0.117.
Negative what?
Right.
Negative 0.117. I think what I did differently, I don't know if it's really correct, but I divided by the standard deviation by the square root of 15.
That's what I did too.
That's what you did too?
Yeah, so
Or,
I did 8.8275 divided by 3.8729.
what was that for?
What?
What standard deviation do you have?
I had the standard deviation at 8.8275.
Okay.
Yeah, and I got the same thing here.
Yeah.
So 46.33
Three.
and 47. Hey, Trevor.
Hey, Colby.
Yeah,
Do you use SPSS or do you use Excel?
I use the SPSS.
Do you have to use like that? I forgot what it's called. That program that brings you into that other desktop. You just have it installed on your computer.
Yeah, that's what I use. This just because it's free, but you can't actually like buy the program if you really want it.
Oh, do you use the VMware View Client?
What's that?
Do you use the VMware View Client?
Yeah.
Oh, okay.
It's also called like the SPSS. That's what the school refers to it as,
Yeah.
or like our statistics class. But then when you look it up, it always has it. It when it's on my laptop, it has that name you just read out, like the view thing.
But you guys know how to use SPSS pretty good then?
Sorry, what? Sorry, I don't know why it's coming out so badly.
Right. Said you guys know how to use SPSS pretty good then?
A little.
No, just like what they've told us to.
Oh, okay. I still don't know how to use it. Is there a link? Did I just not look at a link or something?
Um, I don't know. I'm trying to remember. It was in the like a few lessons ago. They have
Uh-huh.
you add it on, or like they have you download it, like the very beginning. It's got to be in one of the very first folders. I don't know how to give you the link right now.
Oh,
You have
don't
it
worry
now.
about it now. I just wondering. 'Cause I need to study it. I don't
Yeah,
understand the program.
yeah, it's kind of confusing. So you have to go back to like the very like one of the first weeks, but it also shows some. I didn't know how to use it either, and then I watched some of the videos
Uh-huh.
specifically that helped you know how to do it.
Okay, 'cause I mean, like, I'm following you guys. I get the formula and whatnot. It's just that I don't even know how to use the program. I have no idea.
Yeah. Well, we'll just share with you what we if we have to use it. We'll just share for now, but I don't have much more to tell you. You'll just have to go watch it back. And seriously, Colby just reminded me how to do it. I was like, oh, how do you do this again? You know.
Yeah.
So,
Good job, Coleman.
So what did you get for the T-score?
so I got negative point two. Hold on, let me pull that the rating two right. Negative 0.2939292 3. So 0.2939.
Huh.
What did you get?
I got negative 0.117.
Same thing as you got last time.
Yeah.
Okay, so
I'll tell you what numbers I used. So,
okay, yeah, let's do that.
so, so I have for sample mean anyway, 46.733
4, 6. Yep.
minus 47.
Mhm.
Okay, divided by uh, 8.827, and you divide that by
Oh,
square root of 15.
okay. I thought that's what I'd done. Okay, so I want to make sure maybe I did that all right. So I did 8. I did the square root of 15. So I did 8.8275 divided by the square root of 15. Do you happen to have what? And for that, I got 2.27925. Do you happen to know what you got?
Let's see. Yeah, I got 2.279.
Yeah, that's what I got too. And then I got 46.333 minus 47, so I got negative 0.667 for the top part, negative 0.667.
Yeah, And for the top part, I got negative 0.267.
Okay, how is that? That should be the easy part. So it's 46.333, right?
Yeah.
Oh, this one I forgot the 7. Oh man, maybe that's why. I was like, Colby, I keep doing the exact same thing. Hold on. Okay, so 46.733. Oh man, why is it not working very well? 0.7333. So now, wait, that doesn't make any sense. Hold on. 46.733 minus 47. Okay, so negative 0.267. Oh man, sorry. And then divided by 2.7. Okay, so yeah, now I got negative 0.11714. So what you got?
Yeah.
Man, I'm so sorry that took so long. I'm just sitting here like, oh, I've done my math twice. Thanks. Okay. So state the degrees of freedom. So that's 14.
Huh?
So,
Oh, yeah.
sorry. Oh, I haven't imputed it to the data software. Have you done
No.
that?
They want us to input. They want us to check this test statistic by inputting the data into the software, but I don't know how to do that with this software.
Wait a second. That is way out of what I know how to do. Let's see. Computer. That's all with me now. We got a nice box plot. Let's go to analyze perspective. Explore. Statistics. Statistics. Estimate. Options. I don't know what's on here. So let's see. Edit. Man, I'm opening up all these random things you can do, which is pretty crazy. You know, I just don't know how to do that for now.
Because they show you, they don't really show you how to do it, but they kind of like, in the reading, they kind of like show here it is. They don't really show you how to get to it.
I don't really show you how to do that. Now I did the t-test really quickly, and the t-score that they got was 20.504.
How'd you do that?
Well, I just so I went to analyze. Let's see if I can find it again. Report, nope. Let's see if I get it. Hold on, let's see if I can. Okay, I honestly just clicked on it and I don't remember where I got it from. Let's see. I think I did reports. looking at tables. Okay, I did compare means and I did a one sample t-test.
Oh, where's that?
So I went to analyze and then compare means. And
Ah,
then I just did one sample t-test. But that's really off.
so test value. Well,
Did you get 20.5042?
so you put 47 as the test value. Is that right?
Oh, let me check. I didn't think I had it entered. Oh, look at that. I didn't put it there. I just clicked on cool. Insert. Okay, cool. We got the same one. Yeah. That if you do 47 on that, it comes out the exact same.
Oh. Okay.
Woohoo! We got it right. Oh man, I keep interrupting.
Okay. So yeah, I think you said 14.
Yeah. Holy guacamole! This is the second part of all time. It's a lot. Sketch the t-distribution and shape the area which represents the p-value. So then we go on. Can we use the applet for this?
Let's see, sketch the distribution and shape the area. It looks like it's want you to do by hand.
Oh, you just draw it?
Yeah, so you shade it. Oh, they just want you to draw a picture. Draw a
Oh,
picture of
that's
it,
it?
and then use software to compute the p-value.
Okay. So, just the t, and then I would just draw that. And then the p-value would be the two tails, right?
Yeah.
Okay, then you go on. Go back to the software and try to figure out how to do p-values now. Man, I thought I had done so well finding this t-test. Tables, compare means, general model. I do not know how to do p-values. Let's look at the lesson here. Oh, look, it says the p-value is the area that. Okay, so from the lesson, it says that the p-value is what that in this one sample t-test is called the sig two-tailed.
Oh, okay.
If the value is large enough, if the value of t is large enough, SPS gives the value of sig two-tailed, or the p, 0.000. By double-clicking this cell twice, SPSS will display more digits. If t is very large, you will click on the cell and it will show a value of 0. Like the normal curve, the t curve never touches the horizontal axis, so there's always a little bit of the area in the tail, no matter how far out you go. If SPSS gives a value of 0.000, then it's less than 0.000005.
Okay, so it's just the sig that is the p-value, sig two-tail.
Uh-huh.
Okay.
So we got a 0. Oh, no, we didn't. It's point. 0.909, right?
Yeah.
0.909. Okay. So let me just see if I understand this well enough. So that is saying that there is a 90% chance that the mean will land in that shaded area, right?
Yeah, I think so.
So it's essentially saying that there's an extremely likely chance, like a 90% chance they'll either be above or below 47.
Uh, yeah, I guess so.
So then we would reject the null hypothesis.
What?
Then wouldn't we reject the null hypothesis?
Well, you reject it if it's below 0.05.
You accept it.
Yeah, you
Okay.
accept it below that.
Why do you do that?
Huh?
So I think I got switched in my head. So why do we accept it?
Because the p-value is greater than 0.05 our level.
So what does that mean though? Does that mean that it's a probable?
So I think it's the probability that you would get that value.
With with the average being 47, it's a 90% chance. So therefore,
Yeah.
it's a good average. Okay. Thanks. I didn't have that. Must have that switched in my head. Okay. Oh, cool. Well, we just kind of set our English. So 0.9% chance there's 9% chance Okay, let's start the quiz. Okie dokie. Okay, are you guys ready?
Oh.
Oh man, looks like we have to do another null thing. Okay, are you guys on 3?
Yeah.
Okay, so what is that we assume? I said we assume that sigma is unknown.
Yeah.
The null hypothesis is 8 and the alternative is mu is greater than 8 and the population standard is not known. That collects a sample of size n equals 9 and computes these things. Okay. So is sigma known? No. Okay, so 5, what is the value of t? You guys there?
Yeah.
Okay, so it's going to be 11 minus 8
Yeah.
divided by 6 over square root of 9, right? So 11 minus 8 divided by 2.
So 1.5.
Yeah, 1.5.
Okay.
Okay, using the following values. Use the null and the alternative hypothesis.
Well,
Okay, so just copy and paste these into your system. So, Brand, you don't have the software yet, right?
no.
Alrighty, we will share what we are computing here.
Well, I got it. I just don't know how to do it.
Yeah, it's okay. You'll just have to. It takes.
Does it matter if they're in order or not?
Oh,
It shouldn't.
Okay.
And we're doing a 95% confidence interval, right? Or confidence. Is that right?
oh, I don't know.
It doesn't say, does it?
I'm gonna assume 95 there.
It is a 95 because A is 0.05, so yes.
Oh, there you go. Okay, perfect. Awesome. So, what do we use? Okay, so I got the mean. So, Branch, write this down. The mean for the data. So, X bar is 40. Wait. This looks oddly familiar. Hold on, I did the wrong one.
Okay.
I'm like, hey, this looks the exact same. Okay, you ready? The mean is 98.220.
98.0.
220, yeah. And then the standard deviation. So S equals 0.9220. Colby, does that match what you have?
I'm still inputting the numbers.
Oh, okay. I just copied and pasted and they just.
Oh, did it really take it?
Yeah.
I was like inputting it by hand.
You're like, how did you go so fast? No. Hopefully that saves you a little bit. I'm really good at typing in numbers just for that.
Okay, so the mean I got was 98.22.
0? Yeah, that's what I got too. And the standard deviation, what did you get?
0.9201.
Yep, that's what I got too.
0.901?
0.9201.
Oh, I still got 922, I thought. Let me look.
Yeah, that's what I got. 92201.
Okay. Okay, so now we have to. So I just put in 0.2922 for the answer on 7.
Yeah.
Okay, so 8, the t-score would be. Wait, what is. So 98.220 minus. What are they using? That's their mean? 98.6. Divided by 0.922 over. Man, how many? Dang it, we have to count this 1, 2. Do you guys know what n? Or I'm just counting for n. 1, 2, 3. 4.
I got 20?
I think I got 20.
I got 20.
Yeah, 20.
Okay.
Divided by the square root of 20.
Yes.
Okay. Whew. All right, calculator. Okay. 90.22 Okay, so do you guys know what you got on your like the top and lower part?
Oh, for the T score? Is that what we're doing?
Yeah, I'm still solving for it, but I got negative 0.38 on top, and I just wanted to make sure I was entering the right numbers before I solved.
Oh,
So I'll just tell you what I got. So I got oh, go ahead.
I got for the T score negative 1.843.
That's what I got too.
Okay.
8, 4. Do you have questions about that brand?
Oh no, I'm just doing it real quick.
No worries, just let us know when you're there and we can compare.
Okay, what do you guys get for the T-score then?
I got negative 1.843.
Okay, that's what I got too.
Okay, then what is the p-value? We just do this in the software, right?
I think so. Oh,
So,
yeah.
let's do, uh,
Hey
compare.
guys, I got a quick question for you.
Yeah.
Are we on number 9? We agree on 8?
Sorry, I'm not, is 8 the 1.843?
Yeah, we're good with that one, right?
Yeah.
Okay. How do you solve for the p-value again? I'm not exactly sure.
I don't think you can. That would be normally when we do the applet thing, you know? And it'd be the probability or like the area under the curve. But because these are not, because these aren't for the population, they're not z-scores, they're t-scores. Each curve is different, so you just have to do it on the software and it just computes it for you. That's from my understanding. Colby, do you understand it differently?
Yeah, yeah, they're safe. I'm not sure how to do it on the software. Like, less than or greater than. Because, when you do the one sample test, it gives you,
Oh, yeah.
nil, but it doesn't give you any other values other than that. So,
Well,
I was
that's
wondering.
true. That makes sense. Yeah, because what if this one it has to be greater than the t-score, right?
Yeah.
I wonder if you can change it when you. Let's see. Statistics,
6 is always less than.
options. Yeah, I don't know. Let's see. Does it say anything on the homework? Oh, I don't know if we can look at that anymore. Do we know? Have we ever found out?
You know, I think they give you a spreadsheet that can do all this. It's either that or you do it on SPSS, but
Okay, I think. So here's another thought I had, which I don't know if this is perfect. If the two tails, I don't know what to do if I don't know what to do if the two like if you have to highlight the area in the middle, but I do know that for the two tails there, like if it's greater or less than, why don't we just divide it in half?
Yeah, if there's two tails.
Okay. So anyway, either way, the p-value I have here is 0. So I think it's small.
Wait, the p-value is 0?
Yeah. Well, yeah. It's like less than 0.000005.
Oh, okay.
so how did you get that?
Just looking at don't open up that. Sorry, just looking at the t-test, sorry, I can't think. Hold on. Okay. Under the one sample test, the one sample t-test, where you go to analyze, and then you go down to compare means, and then you go over to one sample t-test. And then it says this sig two-tailed at 000. Yeah, and it's 0, and what they have is 0. So even when you double click it, it's still at 0. So
okay. Well, do we just put 0.000 or do we just put 0?
I hope that's right. I feel like.
So it's point is 0.
I guess 0.000. But I just don't know how else we would do it. I don't know how to highlight, like you were saying, Colby, how you highlight more. So
you're double clicking on sig two tail.
like on the numbers on the bottom, or if you like right click, I think it will show you more numbers. But in this case, it's still 0.0000.
Oh, because I'm getting 0.08080.
Oh, let me do it again. Let's see. Yeah, I have just 000. So, oh, but look. Oh, you know what I forgot? Oh, I'm so glad. Okay, hold on. Mine is wrong because I forgot to do the test. I did the test value as the last one. So the test value is 98.6, right?
Yeah.
Oh, I'm so glad you are here. So 0.081, that's what I got. Now, is that what you got?
Value.
0.081, Brand.
Okay.
So we failed to
Well,
reject the null?
Yeah. Say so.
We failed to reject it, right?
Right.
Let me bring up the other Excel worksheet that does the same thing. Let's make sure. Well, I don't even know. I think it only gives me. Oh. Yeah. I guess. Yeah, I guess just use that because I don't know what else to use.
Yeah. I think that, I mean, that's in the homework. That's what it said to do. Not the
Yeah.
homework, but. Okay, so shall we move on here to.
So, let's see. I think we chose 0.05, right?
Yes.
Yeah.
Yeah. So we failed to reject.
Right.
Is that correct?
Right.
Yeah, that's what I said. Okay, so I just started putting that data for this next problem into the software.
Mm-hmm. Alright. Alright. We're supposed to compute a p-value for number 11? Is that
Yeah,
correct?
and at the point, or a 99% thing.
Mm-hmm.
So, analyze, compare. Okay, I gotta. Oh, dang it, I always do this wrong. Okay, hold on. What is the test score 40 for this one?
Yes.
Or the test value?
I got,
I mean,
with my
like,
T4, 006.
what did you just, is it 40 that we're testing out for the null? I can't remember. For the
Oh,
test value.
I think it's 21
Oh,
is our. Oh wait, you said the sample size?
no, like the test value. What are we comparing? Hold on, I can just look. 40.
Oh yeah,
Okay.
it's 40.
Thanks, sorry. Okay. So I got 0.995. Is that what you got?
Yeah. I think we're supposed to do the other one, is I think you're supposed to cut it in half. When it says like less than, greater than, I
Yeah,
think you're
but
supposed to
not for.
cut it in half.
Okay. So are you on 11 or are you on?
I was thinking back to number 9
Yeah.
because number 13 is you take a
Oh,
different alternative hypothesis. It can't, and it's
yeah.
either increase or decrease. So
So number 9, we should just cut that in half. Sorry. We should just cut it in half. So would it be 4,
well,
0?
so the sig2 tail represents the probability on both sides, both extremes, right?
Yeah.
So I think you would cut it in half, and that would give you divided in half. That would give you the probability.
Uh huh. for number 9?
Yeah, I think so.
I agree. So would it be 4, 1? Because it would be
Yeah.
0.0405, and then that would round up to 0.041.
0.1. Yeah.
Brand, did you catch that?
Yes, I did.
And then we'll
Okay, so
have
13.
to,
Oh,
we'll
sorry,
have
go
to,
ahead.
we'll have to change number 10 to reject.
Oh, I'm glad you caught that.
Yeah, I have a question.
Mm-hmm.
So we cut that in half because we knew it was going to have 2 tails, right?
Yeah.
How do you determine whether it's going to have 1 or 2 tails? Do you know?
Well, I think the program always gives you the p-value with both extremes, on both extremes
Oh,
of the test score.
Yeah,
yeah.
it says on the software that it says it's 2 tails.
Oh,
So,
for SPSS, right. Not for Excel, but for SPSS. Okay. Got it.
yeah, for SPSS.
Yeah,
But
okay, I
like
understand.
Colby, yeah, but then we know when it's just greater or less than you only want 1 tail.
Yeah.
So,
Yep. Well played.
so for number 13, the p-value would decrease, right?
Yeah.
Oh
Should-
wait, for number 12, did you guys say fail to reject?
Yeah.
Hey,
So,
question.
So,
What do you guys get for 11?
huh?
What's that?
What we're
what
saying?
did you say?
Oh, I said, oh, sorry. Okay. I said, what did you guys get for number 11?
Oh,
Oh,
point
0.995.
Oh, okay. I didn't
Wait,
know that.
Colby, what did you get?
I got 0.995.
Okay, I thought you said something different. I was like, oh no.
Okay.
So 11 is 0.995, 12 is fail to reject, 13 is decrease,
Okay.
right?
Yeah.
Yes.
Okay. Now 14, so we cut the 11 in half, you're still at 45, 49.49. So
Mhm.
wouldn't we still fail to reject the null because we need less than 0.01?
Yeah. See, compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider?
Wouldn't they be the exact same? Because they aren't changed by greater or less than.
What I was thinking. Same.
Because if you think of all the variables in the confidence intervals, then they aren't affected by greater or less than nulls.
Yeah. Yeah, the only thing we're changing between both questions is just the alternative hypothesis. So,
Yeah, that doesn't change the confidence interval, but what would be what level you're testing them at, like a 0.01 or 0.05.
Right, right.
So they're the same, right?
Yeah, I think so.
Okay, are we ready?
Yeah.
Here we go. Whew, you guys were genius.
oh, I messed up on that one. I guess I accidentally put, oh,
Which one did you miss, Colby? I missed one too.
well, for 14, for some reason I put reject, the null hypothesis.
Oh, darn it.
Oh, for number 10, I put failed to reject instead of reject.
Oh, dang it.
All right, Claire,
I,
you win.
I felt guilty.
All right, still an A. I'll take it.
And
I'll still take it.
Oh, wow.
Darn it, I wish well, I feel like it'd be like, well, they just clicked the wrong thing, and since we really all had the same quiz, can we just
well,
take that?
I guess I thought I put failed to reject, but I guess I put reject. I don't know what
I
happened.
guess I put the exact opposite. Darn it.
Oh wow, still good.
That is a huge bummer.
Oh, all right. Well,
Okay. So just homework for Saturday, and then we'll see you on Tuesday, I guess.
yep.
Okay. Well, I hope you guys have an excellent weekend.
Yeah, you too.
Thanks. We'll see ya.
You got